Interest problems usually take one of two forms: simple interest or compound interest. Let's try a simple interest problem first. Ingrid deposits $1,000 at simple interest in a savings account at the bank. After 1 year, during which she has made no withdrawals and added no more to the account, she has $1,062.50. What was the interest rate paid during this year? With simple interest, we have an interest rate, a time period, and a principal amount, and the problem may be to calculate how much interest is earned on the principal amount without calculating interest on the interest. The formula for simple interest is end balance equals 1 plus interest rate times beginning balance. In this problem, we already know both the beginning and the ending balances, and we need to determine the interest rate. We can do this in general by solving for the interest rate in the formula end balance equals 1 plus interest rate times beginning balance. This implies end balance divided by beginning balance equals 1 plus interest rate. So, end balance divided by beginning balance minus 1 equals interest rate. This result assumes, of course, that there are no further deposits or withdrawals on the account during the year, as was indicated in the statement of the problem. Now let's solve the problem. 1062.50 divided by 1000 minus 1 equals interest rate. So 1.0625 minus 1, which is equal to 0.0625, which equals 6.25%, is the interest rate. So the interest rate is 6.25%. Now let's try a compound interest problem. Ingrid deposits $1,000 in another account and gets compound interest at 6% annually, compounded semi-annually. How much is in the account after 1 year? The compound interest formula is end balance equals 1 plus the interest rate over n, all raised to the kn power, times beginning balance. Now what does that mean? Well, n is the number of times interest is compounded during the year, and k is the number of years during the time period we're looking at. For example, semi-annual interest means n is 2, and if we're calculating total interest over a 3-year period, then kn is 6. With compound interest, we assume that the interest is added to the principal, and so the computation of additional interest must consider the interest that has already accumulated. This formula does that. So in this case, Ingrid is getting some interest on her interest. Since the interest is compounded semi-annually, we must do 2 calculations to get the result after 1 year. Therefore, here's how the formula looks for this problem. 1 plus 0.06 over 2, all raised to the second power, times 1,000. Notice that n equals 2, so we divide the interest rate by 2, and k is 1, so we raise the full expression containing the interest percentage to the second power. This compounding happens every 6 months, so the interest paid at that time is for just half a year. That means the interest rate at compounding time is half of 6%, which is 3%. Thus the calculation is 1.03 squared times 1,000. Now we complete the calculation as follows. 1.03 times 1.03 times 1,000. That equals 1.03 times 1,030, which is equal to 1,060.90. Therefore, at the end of the year, Ingrid's account has $1,060.90 in it.